Welcome. Today we will discuss network performance. In computer networks, performance is defined as the ability of the network to deliver data from one point to another in a timely, efficient, and error-free manner. The performance of a network is influenced by a number of factors, some of which are discussed in this lecture. Network type. The type of network being used can have a significant impact on network performance. For example, local area networks, LANs, are typically faster and have lower latency than wide area networks, WANs. The Internet, as a global network, can be impacted by a number of factors, including distance, network congestion, and Internet Service Provider (ISP) performance, which can affect network performance. Hardware components. The hardware components of a network, such as switches, routers, and network adapters, play a crucial role in determining network performance. The quality and capabilities of these components can have a significant impact on performance. For example, switches with higher processing power and faster communication speeds can improve network performance. Software components. The software components of a network, such as the operating system, network protocols, and applications, also play a critical role in network performance. The efficiency and performance of these components can impact network performance. For example, the implementation of optimized protocols can result in faster communication speeds. Network configuration. The configuration of a network, such as the topology, the number of nodes, and the placement of devices, can also impact network performance. A well-designed network configuration can reduce the distance between nodes, reducing latency and improving performance. Network load. The amount of traffic flowing through a network at any given time can impact network performance. High network loads can result in congestion, which can cause slower transmission speeds and increased latency. To improve network performance, it may be necessary to control the amount of network traffic allowed at any given time. Network latency. Latency, or the delay between the transmission and receipt of data, can also impact network performance. High latency can result in longer wait times and decreased responsiveness. To improve network performance, it may be necessary to reduce the distance between nodes or to implement techniques such as data compression or prioritization of network traffic. Latency calculation in computer networks can be determined using a number of different formulas. Some of the most commonly used formulas include round-trip time, RTT, formula. RTT is defined as the time taken for a packet to be sent from a source to a destination and then back again. The RTT formula is given by RTT equals trans plus prop plus Q plus proc, where trans is the transmission time, prop is the propagation time, Q is the queuing delay, and proc is the processing delay. Propagation delay formula. Propagation delay is the time taken for a signal to travel from the source to the destination. The propagation delay formula is given by prop equals d, s, where d is the distance between the source and destination and s is the speed of light in a vacuum. Queuing delay formula. Queuing delay is the time taken for a packet to wait in a queue before it can be transmitted. The queuing delay formula is given by Q equals L, R, where L is the length of the queue and R is the transmission rate. Transmission delay formula. Transmission delay is the time taken to transmit a packet from the source to the destination. The transmission delay formula is given by trans equals L, B, where L is the size of the packet and B is the bandwidth of the channel. Processing delay formula. Processing delay is the time taken to process a packet at the source and destination nodes. The processing delay formula is given by proc equals P, C, where P is the processing time required for a packet and C is the processing power of the node. These formulas can be used to calculate the different components of latency in a computer network and can be combined to calculate the overall latency of the network. By understanding these formulas and the factors that impact latency, network engineers can take steps to optimize network performance and reduce latency. Bandwidth. Bandwidth refers to the amount of data that can be transmitted in a given time period. Low bandwidth can result in slower transmission speeds and decreased network performance. Increasing the available bandwidth can improve network performance, although this may also increase the cost of network operation. Conclusion. In conclusion, network performance is influenced by a number of factors, including the type of network, hardware and software components, and network configuration. By understanding these factors and implementing techniques to improve performance, such as network optimization, bandwidth management, and monitoring, it is possible to maintain high levels of performance in computer networks. Regular monitoring and optimization can help to ensure that the network is able to meet the changing demands of the organization. Thank you.